In this lesson, we're going to be talking about the Pythagorean Theorem, and we're going to be using those skills that we learned in the last lesson on radical equations. So this is a very, very common and kind of popular theorem, the Pythagorean Theorem, and you may actually have seen this formula before. The formula is a squared plus b squared equals c squared. And one really important note about the Pythagorean theorem is that it only works with right triangles. So this is kind of more of a geometry concept, but you're going to see how we're going to apply some algebra within this geometry concept. So it only works with right triangles. A right triangle is a triangle like you see here. It has a right angle, meaning it has a 90-degree angle within it. And so that's pretty important. And a right triangle is made up of three pieces. It has the two shorter edges called the legs, and these are going to represent the variables a and b. And then you have the long side. That's called the hypotenuse. That's the letter C in the formula. So here's a nice visual on what the Pythagorean theorem is actually doing. It's kind of calculating the area of a right triangle, and you can see that by these little visual boxes that you have here. So if you take A and you square that side length and you add it to the B side length, you'll get C side length. And you'll get the areas will be similar, actually the same. So that's kind of what we're actually doing here. But let's get to kind of the calculation of it. I've got three examples here for you, but I just wanted to show you how the Pythagorean theorem works in reference to an equation here. So it says here, determine the missing side length given the right triangles, and then simplify all radical expressions. So I'm just going to go ahead and write our formula up top here. So it's a squared plus b squared equals c squared. And let's go ahead and fill this out. You can see in this first example, we're searching for a. So this one over here is a leg, so this must be B, and this one over here must be C. So I'm just going to go ahead and label those. And then I'm just going to go pop everything into the formula. So I'm going to say A squared plus 8 squared, that's my B, right? Equals 10 squared, which is my C. And I'm really just going to go ahead and simplify it out. A squared plus 64 equals 100. See where we're going with this? Now we just have a two-step equation that we can easily solve. So let's go ahead and do that. I'm going to subtract 64 from both sides, and that's going to give me a squared is equal to 36. Remember from the last topic that to get rid of a square or a root, we just kind of do the other one. So in this case, I'm going to square root both sides. And these are going to cancel, and I'm going to be left with a is equal to 6. So you can see here that what this actually means is that the side length here in this problem is going to be 6. And you always want to ask yourself, does that even seem reasonable? If the other side lengths are 8 and 10, does 6 seem reasonable? And I say that because if you get a side length of like 400, that's definitely not going to be reasonable. All right, let's try another one. This time we're searching for B. So this one, this side length has to be A, and this one has to be C. So let's go ahead and put this in here. 7 squared plus, we don't know what B is, so it's going to remain as B squared, is equal to 11 squared. Simplify it down. 49 plus B squared equals 121. And now we're just going to go ahead and subtract. So I'm going to subtract 49 from both sides to get my b squared by itself. And that's going to equal 72. Take the square root of both sides. Now I have b is equal to the square root of 72. Now, that's not simplified, right? Can I simplify that down a little bit more? I can. So let's go ahead and do that. You can use your calculator to help you out with this. But the square root of 72 can actually break into 2 and 36, leaving us with 2 root 6. So b is actually going to be a radical this time. It's going to be a simplified radical of 2 root 6. So that will represent this variable here. That'll be the side length. Let's just do one more. This one's a little bit more complicated because it's got some more radicals in it. So you can see that this time I'm looking for C. I'm looking for the hypotenuse. So I can label the other ones as I wish. It doesn't matter which is which. I'm going to go ahead and call this one A, and I'll call this one B. And let's go ahead and put everything in order here. So in this first one, I have the square root of 6 squared plus, and notice how I'm putting everything in parentheses. I'm a parentheses type of person, so I like to use them. And that equals C. All right, now let's go ahead and simplify things. The square root of 6 squared. Well, remember, a square root and a square actually cancel things out, don't they? So isn't that just going to be 6? So that's going to be 6 plus, now watch this. I know that the square root on the 3 is going to kind of cancel out with the 2, but what about the other 2? I've actually got to say 2 squared, so that's going to be 4. And then the square root here is going to cancel out. Do you see that? So really it's going to be 4 times 3. Do you catch that? 4 times 3. And I'm going to write this in another step as well. I'll go ahead and simplify that down. But that'll actually look like this. Kind of tricky, isn't it? So I took the 2 and squared it to give me the 4. And then the 2, the square canceled out the square root, leaving me with 3. So it was 4 times 3. So that's 18 equals C squared. So to get rid of that square, I have to square both sides. So C will equal the square root of 18, but we know that the square root of 18 is not simplified, so we've got to break that down. Square root of 9 and 2. So C will equal 3 root 2. Definitely a little bit trickier, but that's what that means, that C right there represents 3 square root of 2. And that brings us to the end of our lesson on the Pythagorean theorem.